Hello guys, this is my first video on this channel. I'm trying to cover Windows exploitation, not from very basics, but I assume you have some experience previously. As for me, I have previously experience with CTFs, and there are a lot of challenges about Linux exploitation. Um, but there are not so many in Windows exploitation. So I'm aim to fill that gap, and I'm just curious about how things happen on a Windows machine. So let's get started. If you will Google about Windows exploitation, you will probably find this series of articles by Coralan B.E. It's a very great series. There are a lot of useful information, and I encourage you to read it if you don't have previously any experience. But that series is a little bit outdated nowadays because there are examples under Windows XP platform. Now we have Win 10, and there are a lot of new mitigations. For example, you don't have any more executable stack. So I want to show you stuff about Windows 10. So we will look the program which is covered in the first article in this series. We will try to look for extension MonaPy. We will try to get some hands-on skills, and I hope you forgive me my awful English. I'm still learning it. So, this is my first experience in such videos, so don't expect too much. And if you have some ideas, please share it to me. So we will cover the first article. Basically, this presentation will be available in the links below. So just click it and you will find any links that you want. So let me show you a quick demo. So we need to understand where we are and what we can do. Let me close this. I will start, I'm just start the program without any debugging, just to show you what can be done. So this is some old program. It has some basic Stack Overflow, which is covered in that article, but let me just show you. The program can open various formats, and if you will try to open this, you will get a notepad, okay? It can be a calculator or whatever you want. Just the shellcode is spawning the notepad. So this is first demo. So what's next? First of all, why it's possible? It is still possible on Windows 10 because basically of two things. The first thing is it's a Stack Overflow. There is no canary that checks the Stack Overflow actually. So you can control stack and you can control EIP, and there are still models which is not covered by ISLR. So Z models are still on the same image basis every time, so you can jump on it and you can do wherever you want and whatever you have gadgets for. Let me show you how we can find our EIP offset in the file. So I'm using the Palm tools. I guess you're familiar with it. It is used widely in the CTFs, so you must know it probably. So we will just write a cyclic buffer into a file, and we will see which value will be in EIP. So, sorry, cyclic. TMTU. Oh, sorry. Read data. I guess that's it. So now we have this value. It's actually an ASCII value, and we can easily find it using Palm tools function. The function is called cyclic find. So let's write some garbage just before this value, and after that we will write our EIP value. Let it be just 1, 2, 3, 4. Okay. Now let's check again. Oops. We should get 1, 2, 3, 4 value in EIP now. Yep, as you can see, we get it. Let me show you. Oops, here it is. Okay, let's get back to our presentation. The next trick that I want to show you is how to use time travel feature in WinDebug preview. We can use it to find the function in the application which actually has an overflow. So we get a crash, but we don't know which function are really buggy. To do that, you can start debugging from the beginning of application, or you can reverse engineer it somehow. But let's just use this feature because I think it's very suitable right now. So to do it, you need to start WinDebug preview with admin privileges. After that, you need to launch executable advanced and make sure that you check this checkbox. Let me zoom, and here it is. Okay, after you will check it, the WinDebug will write tracing data to this folder, and that will allow you to move actually back in time. So we started. Let's get a crash. So let's open. Now it should crash. It will take a bit because it's really a huge amount of data that can be stored because it traces everything, every every register value on every step actually. So let's just give it some time. Okay, now we have this. This is our EIP value, and let's just write it like this. No, again. Okay, here it is. This is the end of the function, which has overflow. As you can see, it has some stack value. It's a huge actually stack value, which is overflown. So let's just copy this value. We will use it later. Okay. Okay, so let's move forward to our presentation. The original exploit that I showed you is taken from here. You can visit this. It's actually exploit.db. You can see that the guy who wrote it, he used MonoPy and he added missing parts. So the all kudos go to him. Actually, I only changed an offset to make this exploit work. So definitely check this link. So it's generated by MonoPy, and I want to show you how we can debug this return-oriented programming. But before that, let me just show you how what is our approach actually, or you can call attack plan. So first of all, we overflow the stack, and all our data is basically on the stack. So we need to do two things actually. We need to make this stack executable and jump on it. We will not consider the shell code that is actually running a calculator or notepad or whatever. We will just take it from Metasploit. So our job actually is only to call virtual protect or virtual alloc and to jump on a shellcode. So if we can do only ROP, the question is how we can um, call virtual alloc, because as you know, std call in Windows requires the parameters on the stack, but we need our stack to create a ROP gadgets. So the trick here is to use gadget push fd actually. It actually pushes registers on the stack and returns to some address. So if you don't have that kind of gadget, probably you will have problems exploiting your program. So this is the theory, and let's move to the practic. First of all, let's set a breakpoint on the edges our overflowed function and open our file with exploit. Okay, here's our rope chain on the stack. we can just go for it and check what is it doing. So basically it is a stack pivoting. Then we setting up the registers. We are calling this gadget a couple of times to make EIX to our value. Let me zoom. So just check this value while I'm tracing. As you can see, it's incrementing by 100 every time until it reaches 1000, 1000 in hex. So basically, what parameters we should have on the stack before virtual alloc? Our stack layout should look like this. So the first parameter is the stack pointer. It basically points to our stack. Another one is size. We can just use minimal size, which is possible. We can just set here 1 and it will be okay. The next pointer is, the next argument is memcommit, which we just seen in the debugging. So we saw that, let me show you again. We saw that EIX is 1000. So this is the parameter for memcommit, okay? And the last parameter, just a sec, the last parameter is actually protection. So we need to be 40 in hex. Okay, let's trace forward. Okay, here we are. Here we move EIX into EDX. Yes. Now let me show you actually the sources. So this is some padding. This is the first block that we have just traced. And in the end of this block we have EIX to 1000 in hex. This block is just moving EIX into EDX. Okay, the next block is acquiring virtual alloc from import table of this library. And let's see it. Okay, here we are. Here we are in EIX. Virtual alloc address, let's check. As you can see, it's kernel 32 virtual alloc stop. Okay, we can actually set breakpoint here. Okay, and after that we just craft in parameters for virtual alloc into registers just before push fd gadget. Let me set a breakpoint on push fd. I guess that's it. And let's jump on it. Okay, as you can see, it's not just push add and read. We also have some other instructions here. This is the best gadget that we can find in this process. So we need to satisfy some constraint in order to make it work. So as you can see at the end of next gadget, our stack points to virtual alloc, and these are our parameters. I'm sorry, for debugging purposes, I'm just patched some variable, and this is not valid address. Let me fix it. I guess I already fixed it, just not write a new file. So let's start again. Set the breakpoint, load our file. Okay, now we can set a breakpoint on virtual alloc or push of the gadget. Push add, sorry, it's not push of the, it's push AD. Okay, now we have a valid stack and valid params. So when we will jump on virtual alloc, we will have return address. This is the first param for virtual alloc, which is our stack. Let's check it. Yes, as you can see, it's a stack. So if virtual alloc returns success, it returns an address to our stack. This is just some internals. We need to trace it and return from it. Okay. Okay, now we still on some gadgets, which is push ESP red. So we are basically jumping already on our shellcode. Okay, and here's our shellcode. It has some padding, and this is the place where actually the shellcode from the Metasploit framework is starting. So as you can see, it's not trivial to understand what it is doing, but we can just trust Metasploit payloads because they are really great, they are well debugged, and if we will just run, we'll run the shellcode and get our notepad. So I guess this is the demo, and let's get back to our presentation.